Okay, so just seeing how we're going. This should be getting up and running soon. Apologies if you hear baby crying in the background. He is now 7.5 weeks old. Just waiting, running at 7.6 frames per second. Should be streaming now. So where we go, I'm just going to check my sound. Alright, looks like everything's working. Beauty. Okay, so welcome back. It's Sunday, 10th of April. I am going to use this time today to actually go over some of the cool IT stuff we've done at the school this term, just to give you a nice insight as to what's possible. I've not received any emails to give me any indication of what you'd like me to do, so this one's a bit of fun. Now there are some students on here which are have given me permission to use their shots for our media. However, I'd appreciate if you didn't share any of the photos with anyone else. Well, I realise that this video is online. This video may be taken down later on, just to protect the privacy of these students. However, with only a small number of people watching these videos, it shouldn't be an issue. Okay, so to start off with, I'm going to share my desktop and remove that. Okay, so switch this over and remove my Wirecast program and bring up this. Okay, so to give you some indication of what our rooms used to look like, this is our IT classroom, the old IT classroom. You can see it is very, very full. In this case, we have two classes sitting here at the same time. Now, Leon Marston and I both were teaching at the same time. We needed the same. We needed the room. Everything was in here. So we had last year's year 11s sitting around the outside, working on their programming. Oops. We had the year 8s working on the inside on their Arduino boards. Now, the good thing is that we had two people in the class, so we could go around and help them as they needed. Bad thing is there's not a lot of space. So currently there was 42 students in the room. So that's a lot of chairs, and this is a normal sized classroom. You can see there's a huge amount of stuff. Every student has at least one computer. These guys all have one computer plus an Arduino board and all their electronics gear around them. The guys at the back have a computer plus a screen plus a Raspberry Pi up here. We still have space over here for extra students if need be, and our 3D printers running at the time. So you can see here, this is the teacher's desk, which is covered in stuff as we need to get stuff out. So a huge amount of work, or a huge amount of stuff going on at the time, but not a great use of space. Also, the room was kind of crappy. The walls didn't look great. We had to have blinds down all the time because outside of here was just behind the building, little bins and everything. So we needed to move to a new space. So basically, we designed this. This is our computing area. So we had two rooms side by side, S1 and S2. S2, the door is here, and this was designed to be set up as a computing room. So basically, we had all the computers around the outside. So this is our 3D room. Collaborative space in the middle, and some storage cupboards across the back, and 3D printers across the front, glass walls here. S1 is our robotics room. Right, so the door was here. We had to rip up the carpet because we needed to put down lino, because when you're working with electronics gear and small pieces, electronics equipment, we thought, well, this is not going to be a great way because it's so easy to lose stuff in the carpet. If you lose something in the carpet, like a piece of wire in the carpet or a resistor in the carpet, some student has the wrong shoes or no shoes on at the time, they can stab themselves in the foot. So it's really hard to get the wires out of the carpet once they get caught in. So you can see there was quite a lot of stuff. We wanted to put TV screens on the wall, but didn't get the funding to do that. So we just worked what we've got. So you can see this is in the previous time where we've already moved all the screens out and some of the benches. We've then, basically it's just a mess of a room, and yet we're still taking out a lot of the gear already. All right, this is moving out. Just get out of this. Come on, go back. Oops. Okay, so here we've got moved out all the benches, moved upstairs, and this is now our, right, so this is the room. Come on. This is the room once it's basically been emptied. All this furniture was staying there. So now this is our original room, right? So this is what's the room we're moving to. So it didn't look like much at the moment, but it took about a month of effort to get everything up there. Right, so we take all the benches up, get them up is to pull them apart and basically rebuild them once we got them up there. This is the last of the gear, taking it from upstairs, get rid of it. Okay, so now we're starting to get our stuff in here. So this is the S2 room where we just moved everything up there, thanks to the students, and S1 where we're adding more and more stuff. Okay, added in all the screens, sorted out all the wiring that we needed for every single console. Okay, moving in. So this is now, each desk has got all the right equipment sitting on top. That all had to go in the cupboards. We were getting new stuff put around the outside, so that was important. New cupboards, so quite a lot of mess. Okay, so there's lots of stuff, and this room you can see is just messy with all the extra gear. Okay, so then we started to put stuff in. So in this room we put in some cupboards, moved the cupboards in the back. Okay, getting there, right? So now I've got all the gear around the outside. We put the benches in the middle, and I've moved out some of these things. So again, there's actually 40 chairs in here. So 24 chairs on the inside, 16 chairs on the outside, and so it's actually a decent space now. 3D print area, and this is the other space, 3D print room. Now I was going to run chairs and stuff all down this side and this side. In the end, we've gone with the desks on the inside and the space down here to present from. We do want to get a big screen up on the right, in which case the students can see what's going on, but we do have a projector. Basically where I'm standing behind me is the projector, which you can see up here. This is the projector which folds down, which we need to fix up. Alright, so here's our final build. We've got all our robotics gear across here, which has to go in the cupboard, and so on. Right, and this is looking back the other way. So our gyrocopters on the wall, plenty of space for pin-up boards and so on. Okay, and this is students in here using this space for green screening. So, right, so that's our makerspace. Now, I want to get into robotics. So in this space now, in our robotics lab, we can now use it for building stuff. So here's a robotic armor built. Here's all the gear. So now this is our first robotics group. So there's only 8 in the group, and so they had to unbox all the Lego. Right, just love that shot. Right, so basically getting everything out, sorting all out, getting the pieces ready. And then they start building their Lego. Their Lego robotics is getting started. So it's a very simple thing with a brick on top, motors inside, all different sensors that then get attached. So students work through it. This was one of our first things where the students had to start in this corner, drive forward and turn right. Okay, so this is an example of it, where they had to drive forward, and then turn right. Now, unfortunately, all of them going at the same time caused them to crash into each other. So, a bit of oversight on our part. Then we learned how to connect our phones to our robots. So we started driving around the quad, which was great. A little bit of fun. Alright. Then we had a game of soccer. So here we put the robots. Unfortunately, I can't show you photos of that because one of the students had to use my phone. But they had to have 3-a-side soccer with the balloon as the ball. Alright, and then after that we tried Robo Wars. Now what the students did was they put on drawing pins on the front of their robot, so this arm can swing down. Oh, sorry, this is the soccer bit. I get a little bit of footage. Right, so this is them trying to control their robots playing soccer. All right. Okay. When we played the second game. Then we started playing Robo Wars. So in this case, the students had to drive around and try and pop the other people's balloons. Right, so this robot was dead; it didn't connect, so it was just stuck in the middle. If your balloon popped, then you're out. All right, as we can see, students are racing, trying to get around and try and pop them. On the front, you can see this arm here. In the front, they've got a needle, sorry, the drawing pins, so to try and pop the balloons. You can see here there's a robot coming in and trying to get to pop the balloon. Bit of effort. It's no good doing that. Alright, just going to watch. Later on, students started to pop their balloons. Right, get further and further along. Right, so this one's coming down. And some of the designs were quite good, some of them not so good. Alright, here you can see this one's about to pop the balloon. Bang! So that one robot's out. And as we get to the end, this robot, which was on a good arm, has swung down and stuck its pins into the floor, so it's caught. This robot can come down, take its time, walk up, bang. Unfortunately, it had the arm up, so it kind of really held it in the same spot. Next thing we tried to do was conveyor belts. So the idea is that the little block that comes with it comes in here. So this is a sensor. When that sensor is triggered, it turns the conveyor belt on. The idea was that the students had to have to try and get to carry one block from one side of the room to the other, across one desk really. And eventually we got to the point where we had quite a few of them to connect together, but it wasn't the way it would come. But the idea is it's all about coming up with a engineering model that would work. You can see here. Alright, so we've got one going on. Eventually little clips will kick in and it'll lift it. Alright, and it'll carry it along to the next one. Maybe. Alright, so you can see we're not going to win any awards. Alright, next one, and it fell off. Alright, so next thing which we've been doing now with the students is having a go with some gyrocopters. Now we bought these cheap. Bought these cheap. I happened to get these at auction for $50 each. They came with a whole heap of other things as well, so even if they didn't work, they look good in the wall. When I had a go at them, I found that it's interesting that this white one here was not working. One of these ones was not working on both of them. So it's just, and we couldn't work out what was going on. But all the students had to go, and they found that. So there's this one here, that this one just didn't spin. So the other ones worked fine. All right, if I play here, you can see it just spins on the spot. So that's not a great method. Oops. And so then we worked out, well, hang on, if we can manage to take come on. Sorry. If we can manage to take the wheel off the motor off this one, you can see these three spinning, that's not spinning. So if we could take this motor off and replace it with one of the working motors in one of the other ones, then we might be able to get a working model. Alright, and this is now what we've done here. This is one of the students who's actually quite adept at racing it, or flying it. You can see him here, it's hovering, and here we've actually got it flying, which is it's actually quite simple once it gets going. So we'll probably look at getting some more. Now, it does look like these are not spinning. That's because of the frames per second. So they're actually spinning very fast, but it does show you that they do change their speed as they're spinning. But yeah, so that's gyrocopters. Making in Scratch. Right, so here, this is using this area for a different spot now. So we were actually using this for programming. Our students designed these, went down and interviewed these carriage-on kids, receptions, and our students interviewed those students. Then found out what game that they wanted designed, and then they went and made a game for them. Right, so they came away, programmed it all in Scratch, connected up with the Makey Makey. Now, Makey Makey is basically a way of connecting your computer to something else. If you want to have a look at it, go to Makey, so makey.com, I think, or look it up on YouTube, and you'll be able to find some really good example of this. Here you've got the students designing it, and then the carriage-on kids then went along and made how to go with all these different devices, and it was great. Our students loved it. The Karaton kids loved the fact that they had they got the opportunity to work with the Year 9 students. Now, Minecraft's another thing which we've been playing around with. All right, so we're running this off a Raspberry Pi. Come on. Okay, so here we'll find a good setup. Okay, so here I've got a Raspberry Pi, which is a very small computer. This is connected to power. It's also connected to the screen. It also has connected to a mouse and a keyboard and and it has no memory of its own, no hard drive. Basically, you plug in a SD card, micro SD card into it, and that becomes your whole hard drive. So you load the operating system onto the SD card, and that runs the entire thing. Now, each of these students are making their own object in Minecraft, so taking their time. I've got about a week to this, and at the end of it, they're going to design. Once they've built their object, this other students can go and have a look and work out who's done the best job, who's A, B, C, so on. Something good to finish off the year. So we've got a plane, you've got a high tower, we've got another tower, we've got some fort, some very strange things, a castle. This eventually, students working on making the Trojan horse, although it's a bit more like a dog at the moment, and some other devices. The same students were also working on a shipping container. So basically, they're converting a shipping container to a room or something that can be used. So in this case, it's a bachelor pad or something. This one's a shipping container which becomes a restaurant, so you can drive your shipping container up to some place like a Falls Festival or someplace. Open up the sides of the shipping container, so it starts off like this with everything all packed up. Drive up, these sides fold out, and then you've set up all your food. You can see in here there's a kitchen, there's a toilet, and there's two lots of storage, so refrigerated storage and normal storage. So you can just basically run the entire restaurant from out of the shipping container. Other ones that were done, this one's for girl guides. So we've taken the wall off, so we've got sleeping arrangements up the top, so it's one big bunk, walking space underneath with a couple of bathrooms down the end, or a shower and a toilet down the end. We've also got this one, which is a accommodation for a hot family with a big water tank, bathroom, kitchen, bedroom, and so on. This one here, if we look down the bottom, is accommodation for family again. So we've got a bathroom down one end, the parents' bedroom, lounge room, kitchen, kids' bunk bed, bedroom, and then the kids' bathroom. You can see there's one long hallway which allows movement throughout the shipping container. These are 40-foot shipping containers. Here is once students have built their shipping container, they then got onto Unity, imported their shipping container and generated it into a world, and then they adjusted it so that instead of having one camera, it had multiple cameras, so you've got virtual reality. And then they uploaded it to a program called InVR, which they can then run on their phones. And we had headsets which you can put our phones in and look at it in 3D. So this one, which won't look 3D at the moment, you can see, but this is one eye and this is another eye. And so if you've got it on, you can actually see the different things. So this is a kids, basically kindergarten that's built out of a shipping container. The good thing about this is when you have a shipping container like this, well, you go and design it all, and then if you go and build it, you go, well, there's not enough space. This way you can do a walkthrough first before you actually have to go and build it, right? And find out, oh, there's actually not enough room, or it doesn't work. Right, this one's a space pod, so it's very cool. So you actually can't do a walkthrough. So this is the students with all their class set ahead of virtual reality on, allowing them to look around what they're doing. The good thing about this is, it's just a great space, with them all working, all trying out all new things. So yeah, you can imagine this is the classroom of the future where all the different students have got their headsets on and working through different things. Okay, The last one I'm going to show you is our 3D printers. So this is an example of a 3D printer. I'm just going to try and find one where it's actually printing. I guess these ones are printing. No, it's finished. That's probably the only one that's printing. So you can see this printer head. Basically, it's like a hot glue gun where it melts the plastic and then draws with the liquid plastic, and then as the plastic sets, you get basically something formed. In this case, it's a very fine pinhole hole that the plastic's coming out, so it draws very finely. So this one here is building some pieces. All these pieces you can see are being built. This is later on. All these pieces then can be taken out and snapped together to produce our 3D structure. In this case, it's a kind of a dinosaur, a scorpion, crab-like object that the students have worked on. So this is what our Year 5s and 6s are working on with a program called Tinkerplay. Other things that we've done at the school is Arduino boards. We've done iPhone app development. We've done Python, working on Raspberry Pis. We've done all manner of different things and different programs. We've just touched on a few here. So if any of these sound interesting, feel free to get in contact with me. We can and come to the school and check out what we do. I'd love to show off the Maker Lab that we've got. Introduce you to some of the cool features we're trying to do. Places we're going next, we're looking at doing e-textiles, so basically clothes that light up or do things or react. We also want to get into having class sets of gyrocopters, so small gyrocopters that we can either race around the room or around the school or so on. Although we could look at the legalities of doing that. But for small, less than 2 kilo gyrocopters, it's not really that much of an issue. Alright, well, hopefully that has been somewhat interesting. This is probably going to be my last session for a bit, because you guys are all the student teachers going on holidays for a while, and I'm going to use my feed that I'm doing to actually get some other stuff done. So, I hope you'll have a good night and a good semester, good term. Good luck with all your labs and everything. Thanks a lot. Email me if you have any questions, and I'll try and get onto it. Thank you.